Assalamu alaikum wa rahmatullah. Welcome to Amigoscode. My name is Nelson and today I'm really excited to bring you this awesome course that I have for you here. So this is almost a 4-hour course that you have requested. So I'm going to take you from the ground up and teach you Java in a way that when you see the examples, you will fully grasp the concepts. So that's the goal of these series. So this is actually 2-course series. So this is the beginner level, and then after that we will follow up the second course, which at the end I'm going to make sure that you can start writing applications, right? Because that's the goal really, right? So I want you to start building applications, applying for jobs, and you'll see that Java is not that difficult. So you've been requesting it for a very long time, and to be honest, I just took my time to package up the content really careful so that I give you the best content ever. So I'm really excited, and I hope you are. And you should know that learning Java is very essential. So just so you know that Java is still the top 5 programming languages for this year. So you can imagine once you learn Java, the opportunities will be quite a lot. So without further ado, let's go ahead and learn this awesome programming language. Alright, so before we kick off this course, I want to make sure that you are part of the Amigoscode community. So go ahead and join the private Facebook group as well as the Discord, because there are over combined, I think, around 10,000 people all together. And the community is growing and you should be part of it if you are not. So if you have any questions, you can go and ask on the group. So that's the way of interacting with fellow students as well as with myself. Then what I want to request from you is that you practice as I teach, right? I don't want you just to sit there and just watch, what I'm saying and what I'm typing, because that's not the best way of you learning, right? So I really want to add value, and please do take my advice. So practice as I teach. This is all for now. Without further ado, let's crack on. To kick off this course, let's go ahead and learn about the Java Development Kit, or simply known as the JDK, as well as installing it. So the JDK is simply an environment that gives us everything that we need to develop Java applications. And inside of the JDK, we have a few things. One, we have the Java Runtime Environment, or the JRE, and this contains all the libraries and classes for us to develop these applications. But more importantly, inside we have something known as the JVM, or the Java Virtual Machine. So this is what is actually responsible of executing your Java programs. I'm going to explain more about the JVM in a second, but for now, let's understand the JDK version history. So everything started back in 1995, where the JDK beta was released. And then in the following year, the JDK 1.0 was released, so 1996. Then all the way to March 2020, we have the current version, which is JDK 14. And I'm recording this video in July, but in September, a new version will be released, which will be the JDK 15. So you can see from 14 to 15, there is a 6-month gap. So let me now take a step back and go all the way to JDK 1.8. which was released in March 2014. So from JDK 1.8, since the Java 9, which was released in September 2017, a new version has been released every 6 months. So you can see from September 2017, JDK 10 was released in March. So there's a 6 months gap between those two versions. The same with JDK 11 and 12, and the same with 13 and 14, 15 and 16, and finally 17 and 18, and more versions to come. So as you see, there are many versions to choose from. So which one that you should be using and learning as a Java software engineer? Well, you can see that we have the LTS, or long-term support, and this means that that specific version has a long-term support. So when it comes to picking a version to stick with, you should pick a version which has the longest term support. So in our case, the latest version that has the longest term support is Java 11. So Java 17, you can see that that hasn't been released yet. So that will be only released in 2021, in September 2021. So the long-term support for Java 11 will be until September 2026. And also for the Java 1.A has a longer term support, which will be up to December 2030. So most companies, when they choose a Java version, they will choose one which has a long-term support. So you might go and learn, for example, all the features of Java 15, Java 16, but they don't have the long-term support. So companies often, they will not use those versions. So for you, it's best if you learn a version that has a long-term support. All right, to download the JDK, navigate to Google and type JDK and then download, and pretty much click on the very first link. And right here, you see that we have Java SE download. So SE stands for Java Standard Edition. So you have different flavors. If you are going to build enterprise applications, then you might use the Java EE version. But for this course, we're not going to build any enterprise applications. So we're just going to stick with the Java Standard Edition. So right here, remember, I showed you that the latest version is the Java 14 right here. And you have a bunch of links. So let's find the long-term support. So Java SE 11, and right here you have the JDK download. So Oracle JDK and then download. So you might or might not see this message right here, but it simply says that the JDK license has changed. So with Java, you have two versions. You have the Oracle JDK. So this is when for you to run Java in production, so running your Java code to real users, you need to have a license, or you can adopt to use the Open JDK. So for this course, we're going to use the Oracle JDK because nothing changes. So let's go ahead and scroll down, and right here you see that we have versions for Linux, Mac OS, Solaris, and Windows. So depending on your operating system, go ahead and pick the correct version. For me, I'm going to pick the Mac OS installer, and then I'm going to tick this box, download, and there we go. So you can see that it's asking me to create an account. So let me do that quickly. There we go. Now I'm going to create the account. So I've actually verified the account on my mobile phone. So let me close this. Let me log in, sign in. And there we go. So you can see that is downloading. Now let me go ahead and pretty much click on the DMG, and I'm going to double click on this file right here. And the installation process is very simple. So simply continue, install. There we go, my password. And ta-da! So you can see that now we have successfully installed JDK 11. So I'm going to move to trash, and there we go. One of the reasons that I picked Java 11 is because it has long-term support. So if you apply for companies, there will most likely be using Java 11 or Java 1.8. So, usually companies, they take long to upgrade these Java versions, right? And you can imagine the amount of software built on a specific version, and then to upgrade the version sometimes is not a really straight process. But feel free to experiment with other versions that you see. Everything that we're going to cover in this course will be applicable for every single version. So this is just something to bear in mind. You're not just tied to Java 11. So this off now, let's move on. In order for you to write Java applications, you need an IDE. So what an IDE is simply a text editor with lots of features that facilitates the development of applications. So the most popular IDE for writing Java applications, it's called IntelliJ IDEA. So I've actually got a free course on my website where I teach you everything you need to know about this awesome IDE for free. So go ahead and enroll to learn more about this awesome IDE. But for now, everything that I'm going to show you will be really straightforward. And then at the end of this course, I highly recommend you to enroll. Now let's go ahead and download IntelliJ. So I'm going to click on download. And you have two flavors, so ultimate or community. So the ultimate, you need a license for it. The community is free and open source. So again, you can pick the actual operating system, Windows, Mac, or Linux. For me, I'm on Mac, so I'm going to pick Mac, and then I'm going to download the community. So here you can see the actual differences. So the differences are mainly when it comes to writing enterprise applications, for example, using Spring or Java EE, Quarkus, so on and so forth. And also you have, Swagger, JavaScript, and database tools. But to be honest, I always use the community because it does everything I need. So let's go ahead and download the community version. And there we go. So just give it a second. Right, so that has completed. Let me click on it and then drag this to applications, and there we go. So you have now successfully installed IntelliJ. Right, now let's go ahead and configure IntelliJ quickly. So let me open IntelliJ. I'm going to open, and then I'm going to confirm, continue. Don't send anything. Right here you can pick the dark or light theme, so I'm going to go with the dark theme, and what I'm going to do here is simply skip remaining and set defaults. There we go. Now let's quickly configure IntelliJ to use the Java 11 version that we installed. So click on configure. And then right here, you should see that we have structure for new projects and then no SDK. So we're going to change that. So click on the drop down and you can see that we have Java 11, and then make sure that we have SDK default to 11. So right here, you see that we can pick from different Java versions, right? So 14 and then 12, so on and so forth, right? But make sure that the actual project language level, it is set to 11. So now click on apply, okay. And one more thing that I'm going to do is simply increase the font size. So right here, and then right here, let me simply search for font, and then into general, right here, we do have the actual font. So I'm going to change this to something very big so you can see exactly everything I do. So there we go. Now let me simply apply, and let me also click on key map, and right here I'm going to select the IDEA Classic. So this is the key binding that I prefer when using IntelliJ. So this is the one I recommend to most people, but if you want to keep it as a default, that is absolutely fine. Now let me simply apply and then OK. And there we have it. We have configured IntelliJ. All right, let's go ahead and create our very first Java project with IntelliJ. So go ahead and create a new project. So click on the very first button and then right here, click Java and then next, and then go ahead and tick this box right here. So a command line app. So this creates a simple Java application that includes a main class or actually a main method. So now next, and then right here, the project name, let's go ahead and simply say learning and then dash and then Java. And you can see that we have a base package. So right here it says com.company. So here you could, just have your own domain or name. For now, let me simply say com.amigos and then code. I want to touch on packages later, but for now, just change that according to your domain or name. And if you don't have a name or domain, just leave it as default. And then pretty much just click finish. And there we go. So you can see that now it's actually giving me some tips. So I'm going to say do not show tips. So if you want to learn all the tips, go ahead and check my website where I teach this awesome IDE for writing Java applications from start to finish. Now let me simply put this full screen and there we go. So right here you can see that we have a couple of tabs on the top left hand side. So right here I'm going to click on project and you can see that we have some folder structuring right here. So don't worry about this too much for now. I'm going to teach you everything that you need to know in a second. But for now, let's go ahead and write your very first Java application. So simply type system dot and then out dot print line, and then within quotes simply say hooray, my first Java app. And let me delete this line right here. So simply remove that piece of code. And there we go. So I know I haven't explained what all of this means, but for now, just copy along because I'm going to teach you literally everything about this programming language so that you understand. But for now, this line right here simply prints to the console, hooray, my first Java app. Also, one thing that I want to point out, make sure that you type exactly what I have. So system with capital S and then dot out println, and then within these parentheses, make sure that you have double quotes and not single quotes. And also make sure that you have this semicolon at the end. So if I remove that, you see that I'm getting an error right here. So it says that expected semicolon. So this is how Java programming language works. It's very verbose. You need to specify semicolons and double quotes, unlike some other languages such as Python or JavaScript. Now the way you run your application is simply by right clicking, and then you can simply say run main, right? You can run main, or you can click on this play button right here, or this one right here, or on this one right here. So top right corner. So there are many ways of running your application. So let's simply go ahead and pretty much just click on play. There we go. And then run. Just give it a second. And there we go. So you can see that right here, you have hooray, my first Java app. And congratulations, this is your very first Java application. It's very simple, but this is the beginning of your journey towards becoming a Java software engineer. Let me explain to you how the Java syntax work. So let's begin from line number 1. So here you can see that I do have this keyword, so package, and you're going to learn about keywords, packages, classes, methods throughout this course. But for now, I just want to show you how the syntax is structured. So for every single line that you have, you can see right here that we have semicolon. So if I remove this semicolon, this is actually an error. So you can see that if I try and run the program, this won't work. So if I run it, you can see that I do have an error and it says I expected and then semicolon. So this failed to compile, and you're going to learn about compilation next. Now, if I close this, you can see right here we have public class. Again, don't worry about this because you're going to learn about classes. But what I want to show you is, you see where we have the curly brackets. So this curly brackets means that inside of it we can have some other statements. So right here. So if I cut this for now, so we have to open curly brackets and then close curly brackets. And inside, you can see that we have this public static void main. So again, this is a method, and you're going to learn about a method. And you can see here, so we have again curly brackets, opening, and then closing curly brackets. And inside, we have system.out.println, and then you can see that we have a semicolon right here. So this is because it's a single line. So if you have a single line, then you must start with single line. So here you see that we have double quotes. So if you were to use single quotes, this won't work. So this is a string, and you're going to learn about strings, and strings you must have double quotes. So I could, for example, say char. So this is a data type that you're going to learn as well. But for now, just watch what I'm doing, because I want to show you the actual syntax. So if I say char and then a equals 2, this time I can use single quotes because of this data type right here called char. Whereas with strings, we must use double quotes. So what I want to convey to you is that throughout this course, I'm going to type some code, and what I want you to do is to actually follow closely. So as I type, for example, here, if I, type, lowercase s, you can see that this is an error, right? So the actual Java syntax is quite verbose. So here, this needs to be the actual capital S and then system. So when I type, make sure you type exactly what I have on the screen, right? So, and also practice. I've been begging for you to practice throughout this course, and I always beg my students to practice because that's the only way that you're going to learn Java. So if I remove this, and another thing that I want to tell you is that think of Java as learning a new language. Let's say that you want to learn Spanish. You need to learn, the vocabulary, so on and so forth, sentences, and, basically, the alphabet, so on and so forth. With Java is the exact same thing. So here, for example, you see you have package. So this is, for example, hola or como estás in Spanish, right? And then you have public, class, and then you have void. So basically, these are keywords that you need to learn, right? So think of Java programming as a new language that you need to know how to operate with it, right? So how the syntax works. So, and also it has some rules. For example, as I said, the curly brackets, semicolons, and for example here you have string, and then this is instead of curly brackets, so this is square brackets. So if I have, for example, this, it won't take it, right? Because this is the actual syntax of this language. So as I said, make sure you follow closely and type exactly what I have on the screen. And if you have any issues, go ahead and let me know, and I'll be more than happy to assist. Join me in the next one. Alright, inside of IntelliJ, go ahead and expand the project tab, and inside expand the learning Java folder, and then inside you should see SRC, which stands for source, and then inside you see that we have the package that we have created, so com.amigoscode or your domain. So let me expand that, and right here you see that we have this class right here, so main. You don't see the actual extension, but right here you can see that it's called main.java. So let's actually invoke the compiler ourselves, so we see the actual bytecode, which then will be fed into the JVM. So right here you see that we have the terminal, so go ahead and click on terminal, and this is my terminal. So right here you can see that I'm inside of learning-java, and if you want to learn more about how to use your terminal command line, go ahead and check my website where I've got a free course teaching you how to use your terminal or command line, because it's a vital skill that you should have as a software engineer. So what we want to do is cd into src, so right here, so this folder src, and then com, and then Amigoscode. So navigate to the actual path that you have specified within your package. So now I'm going to press enter. Now I'm going to type ls or dir on Windows, and you can see that I do have this file right here called main.java, which is this file right here that you see. Now what we want to do is actually invoke the Java compiler ourselves. So Java compiler comes with the JDK, and the way you use it is as follows. So let me press Ctrl and then L to clear the screen, or simply clear. The way that we invoke the Java compiler is simply by saying Java and then C and then space and then what we want to compile. So we want to compile the main dot and then Java. And then if I press enter, there we go, that's finished. If I type ls, you can see that now we have two files. So we have the main.java and main.class. So what I'm going to do here is, and also you can see that we have this file which popped up here. So what I'm going to do is actually click on main.class. So let's open this class and see what it's inside. So I'm going to accept this, and right here you see that, so if I collapse this, you see that this file is the exact same thing as our main.java. So this actually is a source code recreated from a .class file by IntelliJ IDEA, right? And this is powered by this Fernflower decompiler. So this is actually reading the bytecode and then transforming it into Java code. So what we want is to see the actual file. So right here, what I'm going to do is close this, and then in my toolbar I'm going to go to view, and then right here you see that we have show bytecode. So let me click on it and have a look. So this file right here, this is the actual bytecode which will be fed into JVM. So this is what the JVM understands. So right here you can see that this doesn't mean anything to both of us, but the JVM understands. So from our point of view, we literally don't have to learn, what all of this means. So you can see that it's using some machine code, but basically this is what will be fed into the JVM so that our program runs. Now that you've seen this bytecode from our main.java, so right here you can see that this is compiled from main.java. Let's see how this file right here is fed into the JVM and then executed. So let me actually close out of this. So there's this little button on the top right hand corner, and there we go. So I can simply close this now. If you want to see bytecode for a different class, you know how to do it. To run our Java program, let's go ahead and open up the terminal again, and let me clear this. And what I'm going to do is go back to learning and then Java. So cd and then whoops, and then So I'm going back 3 folders. So right here, you see that now I'm inside of learning dash and then Java. Now the way that we invoke the JVM to run our application is simply by running the main class. So every single Java program should have this class right here, and inside it should be this method. So public static void main string, and then you will learn about this, and then args. So this is an array. You will learn about arrays later. So every single Java program should have this class, and this class contains this method, so static void main, and this is the main entry point to execute your program. So many other languages have the exact same concept. So now let's go ahead and invoke the JVM, and actually need to be inside of src. So cd and then src. So inside of this folder right here, so src, and you can see src. Let me clear the screen. And to invoke the JVM, simply type Java, and then we need to specify the fully qualified name. So I'm going to explain what a package is in a second, but right here you can see that the package is com.amigoscode, and inside we have the class called main. So we need to say com.amigos and then code dot and then main. Now the main will refer to the main.class. So if I run this, you can see that now we have, hooray, my first Java app. Now let me actually go back to com and then Amigoscode, and let me simply rm and then main.class. So now if I do an ls, we don't have it anymore. Let me go back to src and then clear the screen. And if I pretty much just run the same command, so Java and then com.amigoscode.main, if I press enter, you see that could not find or load main class, right? Because we deleted the file. So remember, what we need to do is simply cd into com and then Amigoscode Java C and then main dot and then Java, enter. There we go. Now we have the main dot class again, cd dot and then dot inside of src. Let me clear the screen, and then Java and then com.amigoscode and then .main, enter, and you can see that it works. All right, so we've managed to compile using Java-C on the terminal and then run our program. So right here, you see that we have this main.class, right? So what I want to do is, you see we have this out folder, right? So we have this out folder. So let me go ahead and delete that. So I'm going to delete that. And then basically the purpose of an IDE, or in our case IntelliJ, is to basically compile and run the application on the JVM instead of us having to do everything manually, right? So this is why we have these play buttons. So if I run the program, and if you notice closely at the bottom, it says building, and then, so you actually didn't see it, but somewhere around here, it was saying building, and then it run the actual application, right? But now you can see that we have this out folder. So I deleted it, but we have this out folder. So if I expand this out folder, you see that we have production, learning Java, com, Amigoscode, and then check this out. So this is the actual main.class, which then gets executed by the JVM. So that you know, we don't have to manually compile our applications. I just wanted to show you how it's done behind the scenes, but IntelliJ will take care of things. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's learn about packages. So when we created this project right here, so remember we had to specify the package com and then dot whatever domain that you have. So in my case, com.amigoscode. So what a package is, it's simply a way of you organizing your classes together. So right here, let me simply show you that the actual package is simply a folder structure. So let me actually right click and then reveal in Finder and right here. So hopefully you can see that inside of SRC I do have com and then Amigoscode, and inside we have these two files, so main.java and main.class. So let's remove this main.class because we don't need it. There we go. But you can see that a package is simply a directory structure that allows you to group classes together. So right here we could go inside of the com.amigoscode and create a new package. So let me go ahead and right click inside of this package and then new, and then you should see that we have package. And let's simply name this package as foo. And we're going to create a new package inside of the com.amigoscode package right here, and then bar. Now what is cool about packages is that you can nest them. So inside of bar you could have another package, and right here let me simply say bar and then bar, and you can see that we have bar dot bar. And again, inside of foo, we could also create another package. But let me go back, and now you see that. So if I make this a little bit bigger, there we go. So you see that inside of bar, we have another folder, and inside of bar, it's empty. We don't have anything inside. And inside of foo, it's empty. So let me go back to IntelliJ, and inside of foo.bar, let's create a Java class and simply name it as bar, and make sure it is capital. So all classes in Java should start with uppercase. So enter, and now you see that we have this public class bar. So you're going to learn about everything, but I just want to show you exactly how packages work. And again, let's go ahead, and inside of foo we can also right click and then new, and then it doesn't have to be a class, but it could be a file, for example. But let's go ahead and create a class and simply name it as foo, and then enter, and you can see that now everything is organized. So packages really allows you to group and organize classes for your applications. So if I go back, so I just want you to see that this is just a folder structure. So you have the bar.java, and inside of foo you have foo.java. If you have any questions on packages, please do let me know and I'll give you further explanations. So let me just close this foo.java, and the same with bar.java. Within this class right here, so main.java, let's go ahead and learn about comments. So you saw that when we created this project, we had this line right here. So I think it was write your, and then code, and then here. So what this is simply a comment. So if I run this main method, so I'm going to run it, you can see that we have, hooray, my first Java app. Now, comments are useful when you want to document your code. So they don't do actually anything, right? So if I was to, for example, add forward slash and then forward slash, and you can see that this line right here now becomes a comment. And when you run your program, comments are ignored. So let me show you. So if I run the program again, you can see that now we have nothing on the console because we have commented out this line. So if I remove the comment and then run again, you can see that we have, hooray, my first app. So obviously here you would say this prints to the console. So this would be your comment. Now with comments, you can have two types. You can have a single line comment, which is this one right here, or you can have a multi-line comment. So the way a multi-line comment works is as follows. So simply type forward slash and then star again and then forward slash. So now from this point onwards, if I press enter, so in between the stars, if I press enter, you can see that I do get these stars. But basically anything that I type in between the opening line for multi-line comment and ending line for multi-line comment, I can type anything here, right? So none of this will be executed. So right here again, let me simply say that prints to the console, and let me say this is a multi-line comment. And you can even indent this if you want, just like that. But this is how you write a multi-line comment. So comments are useful to document your code, and you should definitely have them when you have a piece of code which is not trivial for the reader. So comments are there to help other developers when they see your code to understand the functionality of what you wrote. In our simple scenario, we simply have system.out.println, hooray, my first Java app. Right, I want to teach you what variables are. So to illustrate the example, I've got this box right here, right? So variable is simply a box. Just think of it as a box, right? And inside of this box, you can store only one thing, right? So for example, I could take this sticker right here and I could store inside of the box. And now if I want to access my variable, right, I can simply refer to it, right? So this variable or this box right here has a name, and this is how you actually get hold of it, right? By its name. So if I remove this from here, so when you define a variable, you need to specify the actual data type, and we're going to cover data types in a second, but you need to specify what goes inside of this box or variable, right? For example, if I want to, I can take my phone, and by the way, it's a pink phone, don't laugh at me. I could take this phone and then store it inside of this box, right? So now I've got a variable that holds my phone. So variable is something that you will use quite a lot, and also I'm going to show you later on arrays, which you can then store more than one thing inside, right? So for example, you could store both the phone and the sticker, or a bunch of other things inside, right? So we're going to cover that later when we work with arrays, right? And also data structures, which is very important. But for now, just remember that a box, not a box, a variable conceptually is just a box that you can store anything, right? For example, if you want to store, so let me take, for example, these two letters, right? So if you want to store, for example, a series, not a series, a sequence of characters, right? For example, KA, right? So this is a sequence of characters, right? Just imagine this is like a name. You could store that inside, right? Now, anytime that you want to find out the contents of this box, right? The actual value, you simply call its name, and then that will give you KA, just like that. So I hope you understand what variables are. And again, don't worry because I'm going to show this in code, but I just want you to see it first because I think it will make it easy for you to understand. Now, let me go ahead and jump into IntelliJ and show you how to work with variables. As I've explained, a variable, it's simply a placeholder where you can store values. The way you create variables is as follows. First, you need to decide on the data type. So with Java, you have two options. You have primitive data types or reference types. And the syntax goes as follows. Let's say that I want to create a box where I want to store a number inside. So I want to create a number inside. So here, let's simply define first the data type. So I'm going to show you exactly data types and the differences between primitives and reference types. But here, this is a primitive. So here, what I'm saying is that I'm going to have a box of type int. And now I need to name my box, right? So in my case, I'm going to say number and then equals to, and then any value. So in here, let me simply say 100. Now let me explain this again. So in here, this is the actual data type. So in this box, I can only store numbers. If I was, for example, to store a sequence of characters, so for example, Amigoscode, you can see that I'm not allowed to do it. So if I wanted to store, for example, Amigoscode, which is a sequence of characters, I would simply need to have another variable. So this time, just type string. So this is the actual data type for creating sequence of characters. Now I'm going to name my box equals to brand, not box, but the actual variable. And then here, I'm going to say Amigos and then code. And it is as simple as this. So data type, the name of your variable, and then the content inside. So remember, with variables, you can only store one and only value inside. And later, I'm going to explain how you can store more than one value inside of a variable by using arrays, but this will be later down the course. So there you have it. This is how you create variables. Now, as I said, you have two data types when it comes to creating variables. You have primitives, which is, for example, int, or for example, long, or double, for example, if you wanted to store, decimal numbers. So for example, 100.01, if I try with int, I'm not allowed to do it, right? Because this has decimal points. For this, I need to use the double data type. So we've got two data types. We've got primitive data types, which is simply for storing simple values, such as numbers and single characters. And then we have reference types or objects to store complex data types. For example, if I want to find out the current date, so here I can use this data type, so date, and right here, just make sure that you have this import statement, just so that it works. But I'm going to explain what this means in a second. And then here, I'm going to say equals to, and then new, and then date. So you can see the way that we create these are a little bit different. And this is because these are special. So anytime you see new, it's because it's a reference type. And this means that the data type in itself, it's more complex than primitives. So primitives are numbers and single characters. If you have any questions on how to create variables, please do let me know. But next, let's go ahead and learn about primitive data types. And then after that, we're going to learn about reference types. All right, so let me show you all the primitive data types. So we have byte, and right here, I'm going to specify the actual data type, and then I need to give it a name. So right here, I'm going to say D and then byte, right? So this is the actual name. Now, you might be thinking, well, I could name this byte, but I'm not allowed because byte is a reserved keyword in Java. The same with public, static, void, class, package. So if I was to name this as, for example, package, I'm not allowed because it's a reserved keyword. So that's why I'm saying D and then byte equals 2. And then remember, the byte stores whole numbers from minus 128 to 127. So if I say minus 129, try and store that, this will not work. So this has to be 128, and there we go. And even if I put 129, you can see that IntelliJ is actually telling me that I need to provide an int. So minus 128. The next one is short. So the short equals 2, and this stores minus 32,000 to plus 32,000. So I'm going to leave the actual table so you can see the actual ranges, but let me just add silly numbers, for example. There we go. Oops, this is actually more than 32,000. So there we go. The next data type that we have is int. So the int equals 2, and again, int also stores whole numbers. So we can store something like this, and you can see that this is too big. So let me Command C on this, and this has to be lower than the actual max number allowed. And then we have long, and then long equals 2. If I paste the previous number, you can see that it should work. Oh, actually it works, but what we need to do with longs is add either a lowercase l or uppercase L. So I prefer uppercase L. And right here, so these 4 data types, they allow you to store whole numbers, and the difference really is the actual size in memory, right? So byte is 1 byte, short is 2 bytes, int is 4 bytes, and long is 8 bytes in memory. So obviously, so this will take a bigger number, therefore it requires more to be stored in the memory. So as I said, these allow you to store whole numbers. Now, if you want to store decimals, this is when you use the float, and then float equals 2, and then right here I could for example actually let me simply say pi, right? I could say pi equals 2 and then 3.14, right? So it's actually bigger than that, but you can see that the float also is giving me an error, and this is because I need to say capital F or lowercase f. Then we have double, so I can say double, and then let me simply say double, and then pi, this is the name of the actual variable, and I can say 3.14 and then 15. So the difference between float and double is that float is sufficient for storing 6 to 7 decimal digits, whereas the double is sufficient for storing 15 decimal digits. And we're almost done with the actual primitive data types. So next we have Boolean. So right here, Boolean, and let me say is and then adult equals 2, and Boolean simply takes 2 options, either false or true. So Boolean allows you to store true or false values basically. And finally we have the char, and this allows you to store single characters. So name and then initial, equals to, and let me simply say A for Amigoscode, and make sure that this is within single quotes and not double quotes. And there you have it. So if you want to print all of these values to the console, let's simply say system dot and then out dot and then print line, and you can see that this is too much. So let me show you a nice trick. Simply say SOUT, enter, and there we go. So you can see that we have system.out.println. Now I'm going to print the byte, and then I'm going to press command and then D a couple of times. So we have the, and then short, long, int, and then pi, and then double pi. Oops. And finally, we have two more. So is, and then adult, and then name initial. These are the variable names. So what I'm doing is simply print them out to the actual console as we did with your very first program. So now let's go ahead and run this. So I'm going to right click and then run main. And there we have it. So you can see that we have all the values here. So one last thing that I want to show you is if I scroll up, you see that sometimes these numbers can be really difficult to read, right? So you don't know whether this is, 78 million or 7 million or 78 billion, so on and so forth, right? So what we can do is the following. Right here, we can simply add an underscore. So this makes it easy for us to actually read the number. So right here, you can see that this is 8,989. So the max was 32,000, I believe. So 32,000 something. So right here, you can say 32, and then just like that. So you can see that it's much easier. Now we can do the same here. So with integers, so 3 numbers at a time. So underscore there, underscore there. And now you can see that this number is much easier to read. The same with this one. So let's actually start from here. Underscore, underscore, and then underscore. And obviously this works also with doubles. So if I run this again, you can see that it still works, but the output doesn't contain the underscores. So underscores is mainly to help you visualize the actual number. This is all for now. Catch me on the next one. Let's learn about non-primitive data types, or simply reference types. These are very special because you as a Java engineer, you will create lots of these to build your applications. Majority of your code will be based off reference types. So let's go ahead and create this reference type. So simply type capital S and then string, and then let's simply say name equals to, and then new, and then string. So make sure you have the exact same thing that I have. So right here, so simply say string, and right here I'm going to say amigos and then code. Now I'm going to end this with semicolon. Now one difference between reference types and primitives is that reference types, they always start with uppercase. So remember, if I was to have int, so this is a primitive, and then age equals 2, and then let's say 20, right? So you see that this int starts with a lowercase. Another difference is that if, for example, I was to say age dot, you can see right here, I'm not getting any attributes from this variable right here, so age. Whereas if I say name and then dot, you can see I've got many attributes and behaviors. So right here you see is blank, lines, length, region, replace, so on and so forth. But if I say age dot, I'm not getting none of that. Right here, if I delete that, and what a string is, it's simply a reference type that allows me to store a sequence of characters. So remember, we had the char data type. So let me type C equals 2, and this takes, for example, a single character right here. So you can see if I type, for example, Amigoscode, this does not work. So this is where you use the string reference type. There we go. So now I can go ahead and simply say South and then name. So remember, South gives us system.out.println. Now if I run this main class, you can see that I do have Amigoscode. Now what is interesting is that I can say dot, and then right here I've got a bunch of methods, right? A bunch of methods, and I'm gonna explain what methods are in a second, but for now let's simply say to and then uppercase. So now check this out. If I run again, you can see that everything now is in uppercase. So Amigoscode is in uppercase. Everything is in uppercase, which is awesome. So reference types, they give you built-in behaviors, and if you build your own, you can define those behaviors, which I'm going to show you later in this course. And you see that I've used string, right? But there are lots of built-in data types. Remember when I said that the JRE comes with classes and libraries, so there are tons of these classes that we can use. For example, if you want to know the actual current date, you can say local and then date dot and then now, and I need to store this into a variable. So let me simply say local date, which is the type, and then say now, the variable name, and then South, and then now. If I run this, you can see that this is the current date, but I can go ahead and say dot, and you can see that I do have, you know, lots of methods. So for example, get month and then run, and you can see that it says July. So this is a quick introduction to reference types, but I'm going to explain you further how to create your custom reference types. But next, let me go ahead and show you exactly what is the main difference between primitives and reference types. Let's learn about the difference between primitives and reference types. It's very important that you understand, and I'm going to make sure that you fully grasp this concept. So right here, let's start with primitives. So let's define a variable called a equals to 10. And let's go ahead now and define another variable called b equals to and then a. Now what I'm going to do is change the actual value of a. So a equals 2, and then let's simply say 100. And if I South both a and b, right? So right here, I'm going to say plus and then b. So let me actually add a plus here and simply say a here, and then this is b, just like that. So if I run this code, and I'm going to show you exactly something. So right here, you see that a was initially 10, and then b, we said that b equals to a, and then we changed the value of a, right, to 100. So here you can see that, and I'm missing actually equals here, so maybe some equals there. So here you can see that the final value of a equals to 100, and then b is 10. So what is happening here is that when we say that b equals to a, this value right here, so this value that goes into b, is passed by copy. So it's a copy of a, which means that if we change a, this value right here, so b, is untouched. Let me demonstrate this using Keynote. Right, somewhere in the memory in your computer, we have these addresses. So each address is where you store a variable. So in our case, we have a variable a, and this is a primitive, and we store the value 10. And then we said that we have a new variable called b, which was equal to a, right? So what this does with primitives, it simply creates b in a different memory allocation. So 201, and then this is a primitive, and then the actual value 10, right? So it just takes a copy from a to the new memory address. So this is what is happening. And right here, you saw that when we change a to 100, right, b is untouched because b lives in a different memory address. However, this is a little bit different with reference types. Right, so to demonstrate the exact same concept with reference types, let's go ahead and quickly create a static, and then class, and then person. And you'll learn about classes in a second, but for now, just follow along. So right here, let's simply say that we have a string, and a name, and simply say person, and then string name, and simply say this dot and then name equals to name. So right here, and this with semicolon. So right here, this is a class that we can create reference types or simply objects. So right here, let's simply say person, and then simply say Alex equals to new, and then person, and then pass Alex inside there. Now let's go ahead and create a second person. So I'm going to say person equals to Mariam, and then equals to, and then Alex. Now let me jump to Keynote to show you exactly what is happening here. So with reference types, it's a little bit different how these objects are stored in memory. So first we have person Alex, and this is the actual object. So this is somewhere in the memory. So let's say address 200, right? So this is an object. Then what we have is Alex, right? So we have the actual thing, right? Alex, and this is a reference to our object, right? So this is the main difference. So this is a reference to the object. And then we also created Mariam, right? So this is also a reference type, and we said that Mariam is equal to Alex. So now instead of pointing directly to Alex, right? So instead of the address 202 pointing to address 201, it will simply point to address 200. There we go. And this tells us something very, very important. And let me actually show it to you. So right here, let me simply go ahead and say south, and I'm going to say Alex, and then dot name, and then right here, Mariam, oops, plus, and then Mariam dot, and then name, right? So here, let me simply say south, and then before changing Alex. And let me grab this exact same thing here, and then here, let's simply say after changing Alex. And in between here, let's simply say that in here we want to change Alex name. So here, let's simply say Alex dot, and then name equals to, and then let's simply say Alexander. Right, so this is now the actual name. So remember, both Alex and Mariam are pointing to the initial object, right? So now I've changed Alex dot name to Alexander, right? So what do you think the value of Mariam will be? And in here, let's run this program so we can see the actual output. So right here, you saw that Alex has the name Alex, and then we have Mariam, and then Mariam should have the name Alex. But now if I change only Alex, right, only Alex name, we expect Mariam, right, so Mariam to be untouched. So if I run this, there we go. So the output is that we have Alex, but then we change only Alex, right? And right here, when we print Mariam name, it is also Alex. So this is because they're pointing to the same reference. The same if I change Mariam, right? So here, if I say Mariam, so Mariam, and then here Mariam, and if I run this, Alex will lose its name. There we go. So you see that Alex, and then Mariam. So hopefully this makes sense to you. This is something to bear in mind. If you have any questions on this, drop me a message. Otherwise, let's move on. Right, I want to touch upon how you should name your variables. So right here, you said that I actually named this as main, but when it comes to variable, you should name your variables in a way that they make sense. So in our case, we know that this is the actual number 0, so we can name this as number. Or for example, if we have the pi, so the value of pi, we can say pi equals 2 and then 3.1415. So this name does make sense because it represents something. But now let's go ahead and simply say that we have int and then number, and then right here equals 2 and then 1. So you see that now we have a clash, right? Because this name right here is already being used for the number 0. So in this case, what we should do is simply name this as 0 and then 1. So you can see that this variable now tells us that the value, basically the variable name corresponds to the actual value. You should name your variables accordingly. Another thing that when it comes to naming variables is, let's say that we want to store the subscriber count for a given channel. So we're going to say, in this case, int, and then subscriber, and then count equals 2, and let's say that 1 million. So just like that, and this is 1 million. Now you see that this variable right here, it's very difficult for us to read. And what we should really be doing when we have 2 words for a variable name, we should be using camel case style. So what this means is count will become uppercase, just like that. So you can see that now this is much easier for you to read. And also the variables, they should never start with uppercase, so like this, so subscriber count. So there are scenarios where it should be all uppercase or none, and I'm going to show you exactly later. But remember, variables should always start with a lowercase, and then if you have a second word, that second word starts with an uppercase. So right here, let's say for example subscriber count, and then 4, and then amigos, and then code. So you can see that now this is how I'm using camel case to name my variables, because this is now easier for someone to actually read subscriber count for Amigoscode instead of being like this. So subscriber count, and then 4 Amigoscode. You can see that this now is very difficult to read. So remember, when it comes to naming your variables, make sure that the name means something, and also make sure that you use camel case for your variables. Previously, we've learned that if we want to have characters, we simply say a equals 2 and then, for example, a, right? The same if you want a character b, you put it within single quotes and then you can add your character. But the problem here is as soon as I add something else, you can see that we get an error, and this is not allowed. So this is when you use strings. So let me actually leave that line in there. So a string is simply a series of characters. So right here, to create a string, we can simply say string. And right here, let's give it a name. So let's simply say name equals 2 and then new and then string. And then add parentheses and then inside, instead of single quotes, right? So you see that with characters, we have single quotes, but with strings, we have double quotes. And right here, you can add more than one character. So A and then B, right? Whatever. But let me simply say amigos and then code, right? So you see that now we can have more than one character. So a char data type only allows you to have one single value. So let me delete this. Now a string, so this guy right here, so this data type, it is a string, and this comes by default with Java. Allows you to store values, but you can perform a bunch of things. So remember before, so if I go ahead and simply say south and then name, so right here, let's print the actual name. So let me run this. There we go. So you can see that we have Amigoscode. Now this data type, i.e. string, is a class, and then right here we simply say name. So name now is an object. So it's an object of type string. And objects, they have behaviors associated with it. So right here, remember, we said 2 and then uppercase. So this is a behavior. And what this is, the actual term is a method, right? So this 2 uppercase is a method which simply uppercases every single character in this sequence. So if I run this, there we go. You can see that now everything is uppercased. I can also say, let me actually duplicate this line. Oops. Just like that. And right here, we can say 2 and then lowercase. If I run this, you can see that right here we have Amigoscode uppercase and Amigoscode lowercase. So strings are really powerful and you will use them quite often to store text. So let's actually keep on exploring some methods right inside of the string object. So this guy right here, name. So if I say south and then name dot, and you can see that there are tons of methods right here. So right here, let's simply say that we want to grab the very first character. So right here we have char at, and then this guy right here, so this method takes a number, so takes an integer. So if I press Command P, you can see range index, so it takes an integer. So let's say I want the character at index 0. If I run this, there you have it. You can see that we have A. So if I want the character at index 1, you can see that we'll get M right here. Now let's also say that you want to check whether this variable right here, so name, contains the word code. So dot and then contains, and then within, so right here it takes a string code, right? So this is another string. So if I put this so you can see properly, so I can simply say string and then code equals to new and then string and then code. So now I can simply pass my variable. This is the exact same thing. So if I run this, you can see that now this returns a Boolean, true or false, right? So indeed, Amigoscode contains the word code. So if I say contains the word codes, that will fail. You see that it is false. So there are a bunch of methods that we can use with strings. So remember, this is the actual data type. So we've learned about reference types. This is the actual name, right? And and when you say new and then string, this gives you an object. So this guy right here becomes an object, and then you can invoke these methods inside of your object. So we're going to learn more about objects. I'm going to show you exactly how to create your custom objects, but for now, just know that whenever you see a data type that starts with a capital letter, you know that it is a class where you can create objects, and then you can invoke methods inside of that object, right? So one last thing that I want to talk to you about strings is, because they are so used, right? So throughout your programs, this keyword right here, so new string, can be dropped completely, and the same with the actual parentheses around it. So it becomes just like that, and that also becomes that, right? So there is no need for us to say new. So I'm gonna explain what the new means later on, but for now, just know that whenever you work with strings, you don't need to say new and then strings. One final method that I want to show you is, let's say that you want to compare whether name is equal to codes. So we can do that. So south, and then I can say name dot, and then guess what? Equals. There we go. And then code, and this will give us true or false, and you can see that it is false. Of course it isn't, right? So Amigoscode is not the same as codes. So this is all for strings. If you have any questions, go ahead and let me know. Otherwise, let's move on. Now that you understand what a package is and how they work, let me now introduce you to this package keyword. So this package keyword simply tells us that we are inside of com.amigoscode, right? So remember that we defined this when we created our project. So we have a folder called com.amigoscode. Now with package, you will see another keyword called import. So let me go ahead and simply type local and then date. So you see right here, we have local date, but then we have Java dot and then time. So if I try date, for example, you can see that we have date classes, right? And they come from different places. So one comes from java.util and the other one comes from java.sql. So this date right here, you should be using it when working with databases, so dates for databases, and then this one when working with non-SQL dates. But basically, if I select the first one, you can see that we have this import statement right here. This simply says from this package, so java.util, give me this date class so I can use it, right? So now I can simply say date equals to new and then date, right? The same with local date. So local and then date and then equals to new. Oh, actually this time is local date equals to and then local date dot and then now. So with local dates, it's a bit different the way that you create them. So you're going to learn about the new keyword but for now, just follow along because I just want to teach you this import statement. So now we have imported from two different packages. So java.util, oh actually this is java.util, and then java.time, and from it we have local date as well as the date class. So let's do another one. So local and then date time, and you can see that this time the package is the same, right, but a different class. So you'll see these imports simply when you want to bring in classes that belong to different packages. So let me just name this, and this will be like that now, right? So this is the way that you should really be importing these. But as you see, my IDE is actually doing the import for us, right? So we don't have to manually know where each class lives, because I just need to type the date, and you see that we have auto completion, right? So for example, if I also type string, you can see that we have java.lang, right? So java.lang, so this actually is an interesting one. So let me simply say string and then s equals to new and then string. So right here, so you see that we have no import statement. Anything that comes from java.lang, we have no import statements. So let me show you also that another way that you could use a class is by simply saying, so right here I'm going to take this, I'm going to cut it and then put it here, just like that. So this is the exact same thing, so the same here. So I'm going to cut this and then put it here, there, and then there, and then there. So if I put this on a new line, so you can see that this is the exact same thing, right? But usually we engineers, we won't write stuff like this because we want all the import statements at the very top, right? So the only reason why you might want to do this is, for example, so if I put this back, so I've just pressed option and then replace with qualified, the same here. So option and then enter, replace with qualified import, and the same here. So the only reason why you want to do the import explicitly is when, for example, you have two dates. So remember, so right here, if I say date, you have date from java.sql. Now if I press enter, you can see that my IDE is smart enough to know that there is already this class from java.util. So therefore it cannot have, basically it cannot have this line right here. So import and then that, right? Because now it doesn't know which date it should use, right? It gets confused. So the only time that you actually do this is when you have two classes with the exact same name, but they live in different packages. So again, the name of the variable cannot be the exact same. So let me simply say date SQL equals to, and then java dot SQL and then date, and it should be new, and then end that with semicolon, and inside actually we have to pass a number, right? So the actual date. But you see that this is the actual fully qualified name. So I hope that now you understand what these import statements mean and when you should use the fully qualified name. If you have any questions on packages, go ahead and let me know, but don't worry about all of this code right here, because I'm gonna teach you exactly step by step what a string is, what the new keyword is, what an object is, so on and so forth. You're going to learn everything throughout this course. But for now, let's move on. Right, let's learn about the reserved keywords and what it means and why it's important. So reserved keywords are keywords which are used for the language itself. For example, package, public, class, static, void. So what this means is, let's say that we have a variable, so int, and let's say that we want to name this as public, right? And then equals to, and then 0. So this does not work because public, it's a reserved keyword. So right here, I could simply say number, and you can see that this works because number is not a reserved keyword. So there are lots of these keywords. So you will learn, for example, the final keyword. So the same if I was to say void, you can see that it doesn't work, right? If I was to say final, final is a reserved keyword. If I was to say class, you can see that it does not work. So actually, so this guy right here, so main, so this works. So if I say main, this works because this is the actual method name, and we're going to learn about methods later on. So the takeout really is that you should be aware of the reserved keywords, and as you start to learn more and more about this language, you will get to know them and recognize as you see them. But the good thing is IntelliJ, the IDE, is here to help you, right? So if you make a mistake, it will actually tell you that it's a reserved keyword. So remember, you cannot use reserved keywords to name your variables, methods, classes, so on and so forth. All right, let's learn about arithmetic operations. So you've learned about primitive data types, so int, and then let's simply say 10 equals 2 and then 10. So let's also create another variable, so int, and then 2 equals 2, or actually 2 equals to 2, right? So now what I can do is actually perform some arithmetic operation on these two numbers. So I can say int and then addition equals 2 and then 10 and then plus and then 2, right? So this now will store the result of both of these two variables. So there is no need actually for having variables for this. So the reason why I'm actually creating variables is that you see how to use multiple variables, right? But this could be in fact just like this. So 10 and then 2, right? So if I shout this and then addition and then run, you can see that we have 12. So in fact, let me simply do this, and right now you can see that I can simply log to the console 10 plus 2. So let me duplicate this line, and if you want to subtract 10 minus 2, run it, should be 8. There we go. If you want to multiply two numbers together, you simply use the star and then run. You can see that this is 20, so 12, 8, 20. And finally modulus, so the mod, right? So right here, if I run this, so 10 mod 2, this is 0, right? So how many times 2 goes into 10? So 2 goes into 10, so 2 goes into 10 5 times, and the remainder is 0. So if I was to change this to 3, 3 goes into 10 3 times, and the remainder is 1. So if I run this, there we go. You can see that we have 1. So right here you see that I'm actually performing operations on two numbers, but you could definitely do it on more than two numbers. So right here I could say 10 plus 1 plus 2, or actually let's say plus 90. And right here, if you remember BODMAS, so you know, body, multiplication, addition, you know, the actual order that these are applied, this works the same way. So if I was to add plus and then 7, so the order of this is 10 times 2 and then plus 7, so 27. So if I run this, you can see that we have 27. So if you want to actually group them together, you can simply add parentheses in between, so right here. So you can see that this will be the same. So if I run it, 27, but if I was to remove the parentheses there and then say that this now should be 2 plus 7, right, which is 9, and then 9 times 10, you can see that the result now is completely different. So it's actually using the BODMAS, right? So body or brackets, and then orders, division, multiplication, addition, and subtraction. So let me actually have a comment right here. So body, orders, division, multiplication, addition, and then subtraction. So this is the actual order. So this is what's happening here. So if I was, for example, to add you know, plus, or actually minus, and then 10, so now there is, oh, actually I didn't actually run this, so let me actually run it. So you see that it is 90. There we go, 90 instead of 27. But now if I add minus and then 10, there we go, you should see that should be 80, right? So, you know, be aware of BODMAS, and it's the same way that you've learned at school. So this is pretty much how you perform arithmetic operations based on numbers. So we actually use whole numbers, but this could also be, for example, actually let's say 4.5. You know, it's the exact same thing, whether it is whole numbers or decimals, is the exact same thing. So you can perform arithmetic operations on numbers. Right, so you saw how to perform arithmetic operation on numbers, but we have a class that allows us to perform extra operations on numbers, and the class, it's called math. So this is the class. So this class comes from java.lang. So if I press enter, you see that we have no import for java.lang. So remember that I said that with these classes right here, we can perform we can invoke methods. So right here, if I say dot, you can see that we have a bunch of methods that allows us to work with numbers. So right here, let's simply use the absolute, so ABS. So what this means is if I pass minus 10, and let me actually surround this with salt, just like that. So if I run this, you can see that this becomes 10. So basically, if you have a negative number, it turns it into positive. Let's look at some of the other useful methods. So math and then dot. So right here, let's scroll down. So right here we have max. So let's use max. So basically max takes two numbers. So let's simply say 3 point and then 6 and then 10.11, right? So this will give us the max number between those two. So in fact, let me simply surround this again with print statement. There we go. Run it. You can see that the max number between 3.6 and 10.11 is 10. So you can even pass whole numbers. So 6 and 10, 10 is the max number. So if I duplicate this line, and then instead of max, let's simply have min, run it. You can see that the min now is 6. Let's have a look at a different method. So south, and then math dot, and let's use the pow. So pow means power. So what is 5.0 and then power 2.0? So if I run this, you can see that it is 25. I can remove the decimal numbers, so it works with whole numbers as well. If I run it, you can see that it is 25. So this actually returns a decimal. So if you want this to be a whole number, we can simply do this. So we can have int like that. So basically within parentheses, and then simply say int, and then this will actually take the result of this and then put it as whole number. So if I run it, you can see that now we have 25. So let me actually look at some other methods. So south, and then math, and then dot. So if I scroll down, so basically we have lots of these methods. You have round, you have a sine, you have square root of 25. You guessed it right, it is 5. There we go. So 5.0. If you want it to be an integer, you can simply add this bit right here. And what this means is it's called casting, right? So we are casting the result to an integer. So again, let me do it. So int, and then close that, and this is casting. So if I run it, you can see that it is 5. So another thing that we have inside of the math class is, so right here, if I scroll down, basically you can go through this and use whatever you need. So we have subtract, we have 2 degrees, 2 radians, and we have this. So this is one I will show you, the actual value of pi. I've been creating a variable that contained the value of pi, but it wasn't this long, right? So right here, you can see that I can say math.pi and then run it, and you can see the value of pi right here. So this is how you can perform some extra mathematical operations on numbers. Right, let's learn about the comparison operators. So what they allows us to do is to compare values. So let's simply say that we have an integer value, and then Khalid, and then age equals to 18, and let's simply say int, and then Mariam, and then age equals to, and then 20. Now what comparison operators allows us to do is to perform basically operations on these two numbers, or actually 2 or more numbers. So right here, if I want to know whether Khalid's age is less than Mariam's age, I can simply say boolean, and then is Khalid older than Mariam, and then equals. So you can see that this is a very long variable name, but you've learned how to name variables correctly now. So right here, I can say Khalid age, and then bigger, so the greater sign, and then Mariam age. There we go. Now the result of this will be either true or false. So this is why I do have a boolean right here. So if I simply south this, and then is Khalid older than Mariam, and in fact, let me just take this right here and then put it here, and then delete the line above. If I run the program, you can see that no, is not. So Khalid is not older than Mariam. Now I can do the same, but I can inverse the sign. So greater, so the way I remember this is less. So this is the less sign. It looks like an L, right? So L for less. If I now say that Khalid age is less than Mariam age, you'll see that yes, indeed it is true. And we can also say that, or actually check whether Khalid age equals to Mariam age. If I run it, you can see that it is false. But if I change Khalid age to 20 and then run the program, you'll see that these two lines right here, so line number 8 and line number 10, are false, and Khalid age indeed equals to Mariam age because they're both 20 years old. The final comparison operator that I want to show you is almost the same as equal, right? So perhaps you want to say not equal, so you can say not with an exclamation mark and then equal, right? So this says Khalid age not equal to Mariam age. So if I run this, indeed this is actually false, right? Because they are indeed equal. But if I change Khalid's to 21, you'll see that now Khalid is older than Mariam and the age is different. So right here, so true and true. Finally, right here where we say that Khalid age is bigger than Mariam, we can also say bigger or equal, right? Or less, right? Or equal, right? So right here, if I change to both 20, you'll see that both this line, and this line will be true. So if I run it, there we go. So you can see that we have true, false, true, true, and then false. So this is pretty much everything about the comparison operators that you're going to be using with Java. And so that you know, all of these expressions right here, so greater, greater or equal, less, less or equal, equals, not equal, they are referred as Boolean expressions because they either return true or false. Logical operators allows us to combine multiple Boolean expressions. So right here, remember that this returns true or false, right? But what about if I want to say that Khalid age is bigger than Mariam and something else, right? So I want to combine multiple Boolean expressions. So that's what logical operators are. So in fact, let me delete all of this, right? And let's create a Boolean and then is and then adult equals to false. Let's create another Boolean, is and then student equals to true equals to true, just like that. What the logical operator allows us to do is the follow. So we can say right here, let me simply out to the console. So system.println, and inside, let's say that we want to check that is adult equals to true and is student also equals to true. So for that, we can simply say is and then adult, and then the logical operator that we have, the first one is and then is student. Now what this will do, it will check if the first one is true. So if the first Boolean expression is true, it will continue to the next one, and then it will check whether the second Boolean expression equals to true. So basically, and means that all the expressions must be true, otherwise the final output is false. So if I run this, you can see that it is false. But now if I change is adult to true and then run it, you can see that now it is true. But let me go back and then say false here. So let's learn about the or. So let's say that you want to check either one of them have to be true and not everything. That's when you use the or. So this is the or. So either one, right? So you can have 1 million Boolean expressions that evaluate to false. But if you have one Boolean expression that evaluates to true, the whole condition is true. So if I run this, you can see that now this is true. And the final logical operator that I want to show you is or. So right here, if I pretty much wrap all of this, so I'm going to wrap all of this, right? So we can wrap things, and now this is another Boolean expression. So this whole thing will return true or false. So right here, let me also say that. So let me have a second variable here. And what I want to say is Boolean, and then is Amigoscode member. So if you are not part of the Amigoscode community, make sure to check it out. So right here, I'm going to say true. Let's say that you are. And now I can say, so let's say and is Amigoscode member. So if I put this on a new line, so you can see everything. So if I run this, this will be true, right? Because this evaluates to true and this evaluates to true, right? So now change is student to false and then run it. The whole thing should be false. There you go, because this is false. And remember, and whenever you use and, it means that all the Boolean expressions must be true, which is not the case. Now, the last logical operator I want to show you is how you flip the value. So let's say that right here you say is Amigoscode member, right? So let's say that I want to say is not Amigoscode member, or is not an adult, or is not a student, right? So you can do that by simply flipping the actual value. So right here, I'm going to change my condition to say is not an adult or is a student. So right here, is not an adult is true. By putting this exclamation mark, it will flip the value. So now is adult will be true, and then or, so we don't care about this anymore, because as long as this one is true, then this whole statement or this whole Boolean expression is true, right? And then is Amigoscode member. So let me run it. You see that we have true. Now if I say and is not Amigoscode member, I'm going to flip it, but you can see right here, currently you are an Amigoscode member. So if I run it, there we go. You can see that it is false, right? So this evaluates to true, but then this evaluates to false. And with ands, everything must be true. One last thing that I want to show you is, you might sometimes be tempted to say south and then is and then adult equals. So we learned about the comparison operators. So it equals and then to true, right? So you might be saying, oh, I want to check whether this variable right here equals to true, right? And this will either return true or false. So if I run this, you'll see that it is false right here, right? And if I run equals to false, you can see that this will return true, right? But you don't have to do that, right? Because the value itself of this variable is true is actually a Boolean. So what you can do is simply get rid of it, and you can say is adult, and then this will tell you true or false. False is not an adult. And then if you want to check whether is not an adult, you simply flip the value as we learned, right, with the exclamation mark, run it, and then it's true, right? So is not an adult is indeed true because is adult right here. So this variable currently is false. And this is all about logical operators. So just bear in mind that you can combine this with, many things. So for example, if I was to say south, and let me simply say 10. So here I can say 10 greater than 8, right? Or, and then let's say 2 less or equal to 2, right? So we've learned about these expressions, and you can see that now I can also say and then is, and then adult. So basically you can combine most of these things together. And remember, we've learned about strings. So right here, let me simply say string and then name equals to, and then mark. And then I can also say and. So let me put this on a new line, just like that. Oops. And then say and then name dot contains, let's say that the name contains the letter M, right? So you can see that we can combine, these expressions with everything that returns a Boolean, right? So this returns a Boolean. So name contains returns a Boolean, is adult, and here you are actually comparing, numbers, and then you have an or sign with another number. So 10 greater than 8, or, so basically let's say that we want to group these together. So let's group them. So I want to group this and that, right? So let me actually put this like this so you can see exactly. So there we go. I think this is much neater like this. There we go. So I'm saying, is this expression, is this Boolean expression true, and is adult, and the name contains M. So if I run this, you can see that the whole expression is false, right? So this is because is adult is false. So let's actually flip this. So is and is not an adult, and then run it. And you can see that now the whole expression is true. So there we go. This is all about logical and comparison operators. Right, let's learn about if statements. So if statements allows you to execute certain sections of your code depending on the result of your Boolean expressions. So let's create a variable. So let me simply say int and then age equals to, and then 17. And let's say that we want to print to the console whether this age right here is an adult or not, right? So let's, for the sake of it, just say that for you to be an adult, you need to be 18 or over, right? So if it's less than 18, we say you are not an adult. And then if you are, we say, yes, you are an adult. So to do that, we simply use the if statement. So if statement works like this. So if, and then inside right here, we pass a Boolean expression. In our case, I'm going to say age. And then if age is greater or equal to 18, right? If it's greater or equal to 18, we know that it's an adult. So let's simply log to the console and then adult. Oh, actually, hooray. Right. So hooray, I'm an adult. So if I run this, you can see that we get nothing to the console. We literally get nothing. So basically, this condition right here, this was false. Therefore, it didn't execute this condition. So remember that we've learned how to flip values, right? So let's say that we want to group this and that like that. And let's say that you want to check that this condition must not be true. So for that, you can flip the value like that and then run it. There we go. So now you can see that, hooray, I'm an adult. But this is not the case, right? Because the age is actually 17. So if I go back and remove that, so the way that you can then say, if it's not an adult, then do something else, right? So right here, I could simply say south, and then I am not an adult, right? So I could do this, but if I run this, you can see that I'm getting I am not an adult. But even so, if I change this to 18, or actually 18, run it, you see that I'm getting hooray, I'm an adult, and I'm not an adult. So basically this line right here, so line 11, gets executed regardless, right? Because it's not part of this if statement. So if you want this to be part of this if statement, you can say else, right? And then right here, if I go back, I'll actually put this line inside and then indent this. There we go. So now this is what a if statement looks like. So here I'm saying if it's an adult, you print this, otherwise you print I'm not an adult. So if I run, we should only have now one statement. There we go. Hooray, I'm an adult. If I change this to 17 and then run it, there we go. You can see that it says I'm not an adult. We could also combine these. So let's say that I want to, so I'm going to grab this line for now. I'm going to say else and then if. So now I'm actually having a second expression, Boolean expression, right? So if age is bigger or equal to 18, do this. And then I'm having a second if. So if age equals to 17, or actually let's say 16. So if it's between 16 and 17, right? So if age is greater or equal to 16, and then age is less than 18, we want to simply log to the console south, I am almost an adult. And then finally, right, so let me actually run this so you see the output. So there we go, I'm almost an adult. But now if I change this to 15, you can see that we get nothing to the console. This is what you use the else condition for. So else is the last block if none of the above conditions are met. So if I run this, you should see that I am not an adult. And again, we've used if statements with numbers, but if statements are used with any Boolean expressions. So you saw with if statements, you can do if and then else if and then else. You can, get rid of this part right here. So if I remove that, so if and else, right? So if you have an if statement, which is really simple, if you have this scenario only, so I only advise when you have this scenario where you have one if statement, or actually you are evaluating one Boolean expression, and then you need the else if the initial condition is not met. So you can do something like this. So I'm going to replace this whole thing with, I'm going to say string. So I'm going to store actually the value, so this value right here, into that variable. So right here I'm going to say message equals to, and then I'm going to say age greater or equal to 18. So if this is the case, right, I'm going to say question mark. If this is the case, the value of message will be hooray, I'm an adult. And if I put this on a new line so you can see it properly, and then else, this is when you put the column right here, and then this other message, just like that, and then like that. Whoops, just like that. And there we go. Now I can say south and then message. So you can see that this is actually much neater instead of having something like this, right? But as I said, this should be only used when you are evaluating just one Boolean expression and then you need a default value, right? As soon as you have else if, so else, if, right, then things become really complex. And also, if you have, let's say you have, you know, right here, you have two print statements, right? So south, I'm happy, right? So if this is the case, then definitely you can't use the ternary operator, because with ternary operators, you cannot have, so right here, so you see these braces. So everything that you do inside here, so this is the actual logic, you're not allowed to do it with ternary operators. So ternary operators is when you want to return a value, right? As soon as you want to mix logic inside and your if statement becomes too complex, then do not use this. But let me just show you that. So right here, if I delete that, if I run it, you should see that I am not an adult. So it's just printing this part right here. But as soon as I add 18, you can see that it's printing now this value. And this is all about the ternary operator. If you have any questions on this operator, let me know and I can give you further examples. All right, let's learn about this switch statement. So switch statement falls under the same category as the if statement, but a little bit different. So let's say that we have a string, and right here I'm going to name this as gender equals to, and right here let's simply say female, all uppercase, so female, right? So what the switch statement allows us to do is, for example, let's say that we want to check whether you know, the gender is female, male, or prefer not to say, right? So those three, right? We could actually do it with if statements, right? So we could say if, and then gender dot, and then equals, and then female, and then right here we could say else, and then if gender dot equals, and then male, and then again, so else. So you can see where this is going, right? If, and then gender dot equals, prefer not, and then say, and then we also should have like an else, right? So an else, and then this is when you say I don't recognize the gender, right? But you see that this is you know, how we would do it with if statements. And the way that we can do the exact same thing with switch statements is as follows. So let me go ahead and simply say switch, and I want to switch on the gender value, and then inside make sure you have these curly braces, and now I can say case. So when the case is female, and then column, and then right here simply type break for now, simply type break, and then I'm going to say case, and then male, and then type break, and then case. Let me just grab this, there we go, and then say break. And then for the else part, you simply type default, and there we go. So basically, you can see that this is kind of neater, right? So if you compare with this, this is a bit neater. So you should really be using switch statements when you are switching, or you are performing an if condition only on one value right here. All right, so you actually switch the gender and then you check if it's female, male, prefer, not say, right? As soon as you start having, like, complex comparison of operators and greater and bigger than this, then you shouldn't really be using switch statement. So right here you could also go ahead and type out, right? I am a female. So again, let me simply say male, and then prefer not say, just like that. And then right here, south unknown, and then gender, and there we go. And if I run this, you see that I am a female. If I change this to, let's say, female, lowercase, run it, you see that it doesn't know the gender. So if you want to tackle that, you can say dot and then to uppercase. So if you receive something in lowercase, you always try to match it to uppercase. Run it. I'm a female. And if I type, for example, da, see that unknown gender, right? So one last thing here is you see this break statement. So this is actually only in Java 11. I think in Java 12 above, this has been fixed and not needed anymore. But basically this simply says, if this is the case, right, do whatever is before the break statement. Now in our case is the actual system.out.println, and then when you reach this line, break out of this switch statement. So this is something that you actually need for versions below Java 12. So we are using Java 11, so we still need it. So remember, and there is no need for the default branch right here. There is no need to have the break statement. So as I said, so switch statement should be used only when you are switching on single values. So right here, these are the expected values that I have, right? So as soon as you want to start combining, for example, gender if equals to female, and then yada yada, so you cannot do this with switch statements, right? So switch statement is very powerful and neat, and you should be using it when possible. So right here you can see the equivalent for if statement. Basically you can achieve the same thing with if statements, but the switch is much neater, and you should use one or the other when possible. If you have any questions on switch statements, let me know and I'll give you more examples. Let's learn about arrays. So far, we've been able to create variables as such. So int and then 0 equals to 0, and then int and then 1 equals to 1. So these two variables right here, they are independent from each other, right? So this has a different address in memory, the same as this one right here. So what arrays allows us to do is to create one variable that holds more than one value. So instead of us declaring these variables and having these two numbers independent, we can simply create an array and then put both 0 and 1 inside of the array. So let me go ahead and simply say that I want an integer, and the way you create an array is by simply adding the curly braces and then simply say numbers. Now here simply say equals to new and then int, and then simply put the curly braces again. The final thing that we need to do is to specify the size of our array. So when I mean size, I mean how many items that this array can have. So in our case, it can have 2 items. So we want to store both 0 and 1 inside. So now I need to end this with semicolon, and now we have an array. So let me first go ahead and actually print this array right here so you can see the actual contents in it. So to print an array, simply say south, capital A, and then arrays, and then dot, and then 2, and then string, and then simply say numbers. Now let me go ahead and run this. So you see that this is our array. So currently when we initialize the array with 2 spaces, right? So you can see here, so 0 and then 0. So this is the actual size of the array. So if I was to increase this to 2, or actually 3, sorry, and then run again, you can see that we have now 3 zeros. So currently we simply created an empty array, and by default every single number inside of the array which is initialized is 0. So in here, so if I was to, for example, say that I want an array of booleans, so boolean and then boolean, so this is how you say I want an array of booleans. Remove that, and then if I run this, you see that the default for booleans is false. So if I was to say that I want an array of strings, and then new and then string, just like that, and then run it, you can see that the default is null. So this is how you actually determine the actual data type inside of the array. So in this array we want to store numbers, right? So this is why I have int right here. Now the way that we add numbers inside of this array is as follows. Simply say numbers and then curly brackets, and then at the position 0, the 0 position is the first one, I want to put the number 0. We can also say numbers and then at position 2, so this is position 2, we want to store the actual 1, so number 1, and then numbers, and then at position 3, so this is 2, I want to store the actual number 2, right? So arrays, they start from 0, so this is a 0 index, 1 index, and then 2 index, right? But the overall size is actually 3, but the index starts from 0. So this should be actually 2, right? Now, if I run this program, you will see what's going to happen. There we go. So now we have stored in our array 0, 1, 2. So if I was to say in position 1, I want to store the number 2, and then here I want to store 0, and then the last position is 1. If I run this, there we go. So you can see that now we have 2, 0, and 1. So with arrays, when you initialize the size, so size 3, you cannot change it, right? So this is now a fixed size. So if I was to say numbers and then 3 equals to, let's say 44 or 34, and then run it, we should get an error. There we go. So you can see that we have an error, and it says arrays out of bound index. So this is an error, and we haven't covered errors, but just know that because the size of the array is actually 3, it can only have 3 items in it. As soon as you try to add a 4th one, it will throw an error. So let me simply remove that line and then run the program again, and you can see that now it's working. So the last thing that I want to show you is, so right here, let me delete that. So you see that this is one way of creating arrays, but we can do all of this in one single line. So we can simply say int and then numbers equals 2 and then add curly brackets. And in fact, this should be like this, right? So we're saying that we want an int array, and then here we want 2 and then 0 and then 1. So the cool thing about this way of creating the actual array is that you don't specify the size. So it's whatever number of items that you add to this array, that will be the actual size. So in our case, 3 will be the size. So if I was to comment all of this and then run the actual program again, you can see that we have the exact same output. Now I can go ahead and add a 4th item here. Let's add 100 as well. Run this. And there we go. So you can see that we have an array of 2, 0, 1, 4, and 100. And the actual indexes, so this is the 0 index, 1 index, 2 index, 3 index, and then 4 index. If you want to print the actual size of the array, you can simply say south and then simply say numbers and then dot, and then we have a property right here called length. So that will be the actual property of this array, and this will tell us how many items are inside of the array. If I run the program, there we go. So you see that we have 5 elements inside of this array. Now obviously we have an array of numbers, but we could also have, for example, an array of strings. So string and then names, or actually curly brackets to denote an array, and then names equals 2, and then here this has to be in double quotes because the data type of it is strings. So here let's simply say Ali, and then let's simply say Maria. Now let me actually print this. So system.out.println, oops, so south and then arrays dot and then to string and then names. Let me also print the actual size. So south arrays dot and then, oh actually not arrays, but the actual names dot and then length. If I run the program, you can see that we have, so this array this time only contains Ali and Maria, and the size is 2. So there we go. This is how you create and use arrays. If you have any questions on arrays, please do let me know, but they are very useful when you want to store more than one value at a given time. So remember, with a simple variable, so if I was to have this int and then let me simply say n for number, so here I can only store one value. I cannot store more than one. So this is when arrays come to rescue, when you want to store multiple values in it. If you have any questions, please do let me know. Otherwise, let's move on. So now that you know how arrays work, let's say that you want to grab this last element right here from this array. So the way you do it is as follows. So you simply say numbers, and then right here, remember that we've learned that if you want to add a particular number at a given index, you simply pass the actual index. So in our case, this is the index 0, 1, 2, 3, and then 4. So we want to grab the item at index 4, just like that. So now obviously we need to store this into a variable because this now gives us the integer value. So let's simply say int and then simply say 100 and then equals and then numbers, and then 4. Now let me simply say south, and then 100, run. There we go, we have 100. Now let's say that you want to grab the number 4 there, so let's go ahead and simply say int, and then 4 equals 2, and then numbers, and then guess what, index, and then 3, right? So let me actually now do a south here, and then 4, and then run the program, and we get 4 right here. So if I was to change this to 90, now that value is 90, and also the variable name doesn't match the actual value that we are getting from the array, right? But you get the point. So let me actually go back on that. So leave it as 4. Now if I was to try to access index 5 like before, right? So this array can only contain 5 elements, but here I'm trying to retrieve index 5. So this is index 0, 1, 2, 3, 4, and then index 5 is non-existent. So if I run this program, this will fail. So check it out. So you see in this error, array index out of bounds. So just be sure that whenever you're trying to access an index from an array, it is within the actual range inside of the array. Now here I can simply say 4, and let's say that, you know, just for the sake of it, you want to grab the last index. So but let's say that you have let's say you got 4 here, and then you have 90, and then you have 78, right? So let's say I want to grab the last index, so I don't want to count really all the indexes, so I can simply say numbers dot and then length, and remember the length will give us the actual number of items inside of the array. So here 1, 2, 3, 4, 5, 6, 7, 8. If I run this should fail. Yeah, this should fail, and this is because, remember, for us to grab the index, we need to start from the 0 index. So here I need to say minus and then 1, and then run the program, and now we get 78 right here. And there we go. This is how you retrieve elements from an array with a given index. So next, let's go ahead and learn about loops. Right, let's understand what I++ means and I minus minus. So if I get rid of this, and let me go ahead and create a new variable, so int, and then simply say number equals to 0. So now I can say number and then plus plus, and then simply print the actual number. So number. So this is the following. So you see that this simply says take the current value of a number, and then plus plus simply says increment it by 1. So this is the exact same thing as saying number and then equals to, and then take the current value of number and then plus and then 1. So this is the exact same thing. So if I run it, you can see that we have 1. The same with minus minus. So right here, if I say number minus minus, and then run it, you can see that we have -1, and this is the exact same thing as take the current value of number and then -1. If I run it, you can see that it's the exact same thing. And if I go back, so if I press Ctrl Z there, so you see the actual loops again. There we go. So here, this is exact same. This is what I was doing, right? So here I could say I and then equals to I and then +1. It's the exact same thing, but I++ is the actual shorthand version, right? I++. So in here, so let me simply remove this. So if I paste that again, so if I say number plus plus, right? So number plus plus, that increments it by 1. But if you want to increment by 2, this is the way that you do it. So number and then plus and then 2, right? So the I++ is only a shorthand when you want to increase the number by 1. There is also another way of actually increasing numbers. So instead of you saying number plus 1 or plus 2 plus 3, you can simply say, so number equals 2, and then actually plus and then equal, and then the actual number, right? So here I'm saying number plus equal and then 1. So this increments the number by 1. I can say 5. So if this initial number is, let's say 3, so the output of that will be 8. There we go. So if you want to decrement the number, you can simply say minus equal and then 5. Run it. You can see that it's minus 2. So there we go. So basically this is the exact same thing as number equals 2 and then number minus 5. And finally, if you want to increment or decrement by 1 and only by 1, this is when you say number and then plus plus, or number and then minus minus. If you have any questions on this, drop me a message. Otherwise, let's move on. Right, so you saw how to loop through arrays using this for loop, and this is the for I loop. So in Java, we have something called enhanced for loop, and enhanced simply means that it's a better version of you looping through arrays. So the enhanced for loop works as follows. Simply say for, and then here simply say int. So this is the actual data type, and then simply say number, and this is the actual variable, and then say column, and then numbers. So basically I'm saying for numbers, take the individual numbers one by one, and then put it inside of this variable right here called number. So now open and close curly braces, and I can simply say south. And let me simply say south here, enhanced for, and then loop. And now I can simply say number and then run it. You can see that it's the exact same thing. So enhanced for loop 2 0 1 4 100 4 90 78 77. So this loop right here, so this loop right here, and this one are the exact same thing. But the difference here is that with this loop, right, I do have access to the index value, right? Whereas in here, I don't have access to the index. I only have access to the actual number itself, which means that, for example, here, if you want to for example, if you want to check the next neighbor, right, inside of this array, so the next neighbor of 2 is 0, you can't do it with this, but with this one here, you can. You can simply say I and then plus and then 1, and this will give you the next neighbor, right? So this is something to bear in mind. So this enhanced for loop doesn't give you access to the actual index. So you saw that we have numbers, but this also works with a string array. So string and then names. Oops, I always forget the actual brackets. And then names equals to right here. Let's simply say Anna and then Ali, and right here. So now this has to be a string. So that's the individual data type inside of each element. So string and then string, and then here this will be name, or you can name it as n, whatever you want, right? But as we learn how to name variables, they have to mean something. So name, and then here simply say names, which is the actual array, and then simply print name. So this guy right here. So if I now run the program, you can see that we have Anna and Ali. Let me teach you something very nice that you can do with your IDE. So you see that for us to create a loop, we simply have to say for, and then int I equals to 0, so on and so forth, I plus plus, and you get the idea. So instead of us doing that, we can have some help of our IDE. So let's say that we want to loop through numbers. So from left to right, simply say numbers, and then dot, and then for, and check this out. So you have for I, for R, and then the actual normal, or actually not normal, but the enhanced for loop. So for I, so for and then I'm going to pick that one, and you can see that we get everything filled in, right? So let's try the other one. So numbers dot and then for and then R. So this is the actual reverse, right? So from right to left. Enter, and there we go. So you see that this is much quicker, right? So this is why IntelliJ, it's amazing, and you should really be using awesome IDEs like this one. So finally, if I say names dot and then for, and this is the enhanced for loop, enter, and there we go. So you see that I was able to create these loops in seconds. So there is another way that you can loop through arrays, and let me quickly show you. So this is more on the advanced side, but I still feel like I should teach you so that you know that there are many ways that you can loop through arrays. So go ahead and simply type arrays dot and then stream, and as I said, this is more on the advanced side. So simply say numbers and then dot and then for each, and then simply type system dot out and then colon print line. So again, this is on the advanced side of things, and I don't expect you to learn this, right? But this is one of many ways that you can loop through arrays. So here, if I want to loop through names as well, simply say names, and if I run this, you should see that we have the actual output right here, and this is beautiful code. But as you progress through your journey in learning Java, I'm going to make sure that you understand this as well. But this was just a bonus tip that I wanted to give you. This is all for now. Join me on the next one. By now, you should be familiar with looping and indexes, so on and so forth. So let's say that you want to loop, so names and then for, and this is the enhanced for loop. So here, let me simply say south and then name. So if I run this program, you should see that we have Bob, or actually let's start from here, Anna, Ali, Bob, and Mike. So what the break keyword allows us to do is to simply break out of the loop. So if I was to simply type break in here, so this will give me an error, right? Because by this point, so this will break and then this line will never be executed. So if I change the order, now you can see that we will print once and then break out of the loop. So we should see only Anna right here. So if I run this, there we go. You can see that we have Anna. So we could do something more clever. So let's simply say if and then name dot equals and then Bob. So if the name equals to Bob, we want to break out of the loop, right? So now we should go and print Anna, Ali, and then if name equals to Bob, we simply break. So here, let's simply say South and then name, right? So if the name equals to Bob, we're going to break out of this loop. Otherwise, we're going to print the actual name. So if I run this, we should see only Anna and Ali. There we go, Anna and Ali. So as soon as we reach Bob, we break out of this loop, and then Bob and Mike will never be printed. So that's the function of break. So break simply breaks out of any loop. Now the continue keyword is as follow. So right here, so let me simply say if name dot and then starts with and then A. So if the name starts with A, so right here you see that we have Anna, Ali, Bob, and Mike, right? So what continue does, so if I simply say continue, so what continue does, continue, instead of breaking out of the loop, it simply goes back to the beginning of the loop. So in this case, we have name starts with A. If that's the case, we're not running anything after this line right here, actually, sorry. So anything after this line right here. So if this line is executed, we simply go back to the loop and then run everything again. So for this example, what's going to happen is the first time that the loop goes around, so this is Anna, starts with A, continue, and then this line right here is never executed. And then it goes and it checks the second one, Ali, starts with A, yes, don't execute this line, right? So don't execute anything that comes after continue. And then Bob, does Bob starts with A? No, print this line. Does Mike starts with A? No, print this line. So if I run this, we should only see Bob and Mike. There we go, Bob and Mike. So there we go. This is how you use the break and continue keyword. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's learn about the while loop. So the while loop allows us to loop while a Boolean expression evaluates to true. So the syntax is as follows. So while, and then parentheses, and then right here, so this part right here, so this is the actual Boolean expression. So right here, if I say false, you see that IntelliJ is telling me that this is an unreachable statement, right? Because if this is false, this won't be executed. But if I change this to true, you can see that now I can say South, and then here let me simply say hi, right? So if I run this code, this will run forever. This again will run forever. So if I run it, you should see on the console that we have hi, and you can see here it's just running forever. So this will never stop. So what I'm going to do is I'm going to pretty much just stop, because this is actually consuming lots of resources, and I'm going to declare a variable. So let me say simply int and then count equals to and then 0. Now here I'm going to say while count is less or equal to 20, I'm going to print the value of count. So I'm going to say actually count and then plus and then count, and then in here I'm going to increment the value of count. So I'm going to say count and then plus plus. Now if I run this, this should only run 20 times. So there we go. So count 20, and you can see that it ran exactly 20 times. So in the event that count equals to, let's say, 21, run it. You can see that this does nothing because 21, so count is actually bigger than 20, so therefore this won't be executed. So this is how you use the while loop. So basically, while pretty much just runs your loop while the Boolean expression is true. As soon as the Boolean expression is false, then it pretty much breaks out of the loop. The final loop that I want to teach you is the do while loop. So as you saw previously, the while loop simply executes the block of code inside of the curly braces while a condition is true. So if I run this, so you remember what we've done before, you see that it prints all the numbers from 0 to 20. If I say that this is 21 and then run it, you can see that this does nothing. So let's say that we want to print the number at least once inside of the loop. So we want to know the current number and then perform the actual loop. So this is when we have the do while loop. So do while loop works as follows. So do, and then right here I need to grab all of that and then remove this parenthesis here. So basically it's a little bit different, but you can see that now if I put this inside, and what this loop is saying is that no matter what, I'm going to do this at least once while this condition is true. So at least once, right? So remember, we changed this to 21 with a while loop and nothing got printed to the console. But now if I run this program, you see that we have at least 21, right? Because this is actually executed at least once, but then obviously this condition is false, so then it doesn't execute this piece of code again. So if I was to change this back to 0, this will work in the exact same way. So there you go. So 0 to 20, and basically it's just printing this, increasing the value of count, and then checking, is count less than 20? Yes. Do this again. Is count less than 20? Yes, until count is less or equal to 20, and then it pauses. But the difference between the normal while loop, so this while loop, so while and then true, and this one right here, so let me collapse this. So the difference between do while and while is that do while executes no matter what at least once. So this block of code here is executed at least once, whereas the while loop, it doesn't. So if you need something to be executed at least once, then use do while loop. Otherwise, just use while loops. If you have any questions, drop me a message. Otherwise, let's move on. Right, let's go ahead and learn about the scanner class. And basically the scanner class allows us to take user input from the console. So let's create a very simple program that takes the user name and then prints to the console hello and then the actual name. So go ahead and simply type scanner. So scanner, and this comes from java.util, and make sure it's capital S and then scanner. So right here you can see the import statement from java.util scanner, and then let me simply name this as scanner equals to new and then scanner, and then within parentheses simply type system dot and then in, lowercase in, just like that. We have now this variable right here, which is an object, And I'm going to explain objects, what objects mean in a second. But this variable right here now can take user input from the console. So if I run this program, you see that the program runs, and in the console nothing happens, and then the process finishes. So the program just exits. So what we want to do is actually say South. So let's simply say South, and then what is your name? And what we're going to do is to take the actual user input, we will simply say scanner dot and then next and then line. So next line means take the actual string that comes from the console. So right here, you'll see this in a second. So right here, and then user and then name. Now if I run this program, you can see that we have what's your name, but the program does not exit because it's just waiting for user input. So let's simply say Amigos and then code, enter, and now you can see that the process has finished. So now we know that this username variable right here contains Amigoscode or whatever comes from the console. So let's simply say South and then hello and then plus username. So if I run this, what's your name? I'm going to type this time Maria, enter, and you can see that we have hello Maria. Now let's also take the actual age, and then from the age we want to calculate the actual year of birth. So for that, let's simply have South again, and let's simply add some spaces here. So we want to have how old are you, and then right here we're going to use the actual scanner again, dot and then next and then int. So we want that to be a number. We're going to store that into a variable, age equals 2, and then what we're going to do is simply subtract the current year minus age, and that will give us the year that the person was born. Right here, let's simply say local and then date dot and then now dot and then minus years and then age and then dot and then get and then year. So this now returns the actual year that the person was born. So now I can go ahead and simply say South and then you were born in and then plus year. Now let's run the program. So if I put this a bit bigger, so what's your name? So let's simply say Ali, and then hello Ali, how old are you? Let me simply say that Ali is 21, and then enter, and there we go. You were born in 1999. Let's also say that we want to check whether Ali is an adult or not. So if I say if and then age is less than 18, we want to say South and you are not an adult, else I want to take the exact same print statement and then simply say you are an adult and then put a smiley face. There we go. So if I now run this program, there we go. What's your name? Let's say Zineb this time, and then you can see hello Zineb, how old are you? Let's say she is 25. There we go. So you see that you were born in 1995 and you are an adult. If I run the program again, and then Zineb, how old are you? 25. Or actually, now let's say 17. There we go. You were born in 2003 and you are not an adult. Maybe we could put a sad face here, right? And there we go. So I just wanted to show you how to build a very simple program that takes user input from the console. Now you know how to use the scanner class. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's learn about methods. So methods is simply a block of code which only runs when it's called. We can pass data into a method. This is known as parameters. In a nutshell, methods are used to perform any logic. When I mean logic, I mean actions, whether it is to transform some data or any piece of code that does something. So we have two types of methods. We have built-in methods, and these are methods provided by the Java runtime environment. And then we have user predefined methods. So those are methods that we build ourselves. So just an example. So right here, so check this out. So you've seen that system, oops, not system tray, but system dot out dot and then print ln. So print ln is a method. And right here, so these parentheses simply implies that we are invoking the actual method. So I said that with methods, we can pass some data, and these are known as parameters. So right here, you've seen that we've been printing to the console. So here, let me simply say hello, and then run this. There we go. So you see that we have hello. So this method right here, so this method println is provided by default. We didn't write this method ourselves. So the same with, for example, if I create a string variable, so string, and let's simply say brand equals to, and then Samsung, and right here, let's go ahead and simply say South. Right, so println, so we are invoking this method, and then let's simply say brand dot and then to uppercase. So here you've seen this as well. So this also is a method. So right here we have these two parentheses, right, which denotes that we are invoking the actual method. And in this method, we are not passing any data. So this method simply transforms this data right here. So this one right here, so Samsung. So basically it transforms it into uppercase. If I run it, you see that everything is in uppercase. So let me show you one more method. So right here, if I say brand dot and then contains, oh actually, so basically right here you can see that there are lots of methods, right? And then let's say that starts with, so right here, so starts with, and then let's simply check whether it starts with s, right? So we are passing some data into this method right here called starts with, and what this method returns is a boolean. Starts with and then s equals to, and if I now shout to the console that variable and run it, you can see that it is true. I can change this to lowercase s, run it, it is false. So I can take this, and let me just take that and then delete this line and then print it inline, sorry. And now I can duplicate this, and I've got ends with s. So right here, let me actually change this to uppercase. So now if I run this, you can see that starts with capital S, true, ends with lowercase s is false. I change that to lowercase g. There we go. So true and true. So if I type brand and then dot, you can see that we have a bunch of these methods. So we didn't write any of these methods, so this is given to us by default. So with Java, there are many classes, such as the string class, that comes with a bunch of methods that we can use. And throughout your journey in learning Java, you will start, remembering these methods as you use them again and again and again. So next, let's go ahead and write our very own method. Let's go ahead and create a char array, and in here let's simply say letters equals to, and then right here let's simply add some letters. So A, and then B, and then C, and then finally D, right? So let's have D actually 2 times, or actually 3 times D. So we have so A 2 times, B 1 time, C 1 time, and then D 3 times. So let's create a method that will count the number of occurrences for any given letter. So right here, outside of this main method right here, so this, in fact, so the public static void main is a method, and you can see that the parameters are a string array, right? So called args. So this is more on the advanced side of things, but don't worry about what this actually means and where it comes from, because you will learn that in later courses. So right here, let's go ahead after the main method. For now, simply type public and then static and then int and then count and then letters and then occurrences and then open curly brackets, and for now simply return. So let's return 0 for now, right? So public means that this method is accessible by other classes. So you'll learn more about the access modifiers of a method. Static means that this method belongs to a class. Again, don't worry much about it because you will learn this later. And then int, so this int is the actual return type of this method. So right here I'm saying return 0. So if I was to say 0.0, this doesn't work because I've told this method to return an integer. If I wanted a double, I could say double. You can see that now this works. So simply say int, and then here for now let's simply return 0. Now right here, this is the actual name of the method, and you've learned how to name variables, right? And I said the way that you name variables and methods, they are the exact same thing, and you should be naming your variable methods camel case. Now in here, so 2 sets of parentheses, this is what we can pass into this method right here. So for now we're not passing anything, but just follow along. Now what I'm going to do here is simply invoke this method. So I'm going to call the method the same way that we invoke system.out.println. I'm going to invoke this method. So here I'm going to say count occurrences, and there we go. So now I'm actually calling the method. So if I run this, nothing happens, right? Nothing happens because this method is not doing anything really. So it's just returning the actual value 0. So here I could say int and then count equals 2, and now if I simply print the actual count value, So count and then run. You can see that we have 0 right here, right? So if I also change this to -1, run it. There we go. See that we have -1. The same if I was to log, so south, so inside of the method, so method, and then let me copy that, was invoked. So I'm saying that every time that you invoke this method, print this and also return -1. So if I run this, there we go. So you can see that method count occurrences was invoked, and then -1 is the actual return, which we are printing in line number 9. Now, the way that you can pass data inside of your method is as follows. So in here, so in this set of parentheses, what I'm going to do is simply say that this method will accept an array of characters. So I'm going to say char, and then this will be the array, and then I'm going to say letters. Now this method will receive this array, and in here you can see that we have an error. So this is actually red, and this is because it's saying expected 1 argument but found 0, right? So here what I'm going to do is simply take my letters and then pass letters here. Now you can see that the data type is an array of characters. So if I was, for example, to pass a string, so this will not work. If I was to create an array, so an array of strings, and let me simply say a name, names actually equals 2, and empty for now. So if I was to pass names inside, this will not work unless I change this to string. So this will match the actual data type, and this will work. Now let me actually go back. There we go. So there we go. So I'm going to go back here. Now let me pass letters inside, and this is how we pass data inside of our method. Next, let's go ahead and implement the actual logic that will count the number of occurrences for any given letter. Right, so we want to find out how many times, for example, the letter A appears in this array. So in our method, we are accepting the array, right? But we also need to accept the actual character that we are looking for. So here I'm going to say comma, and then this will be a char, and let me actually put this on a new line so you see everything properly. So this will be char. I'm going to name this as search, and then a letter, right? So now again, this is complaining because I need to pass a letter. So I'm going to say comma, and then again, this has to be a character. So a character of type char, right? Now I do have both the actual letters inside as well as the search letter. So in our case, the letters is the above array, and then we want to search for letter A. Now let me remove this print line, and what I'm going to do is simply say south, and then I'm going to say arrays dot to string, and then letters, and let me also south the actual search letter, right? If I run this, you should see that we have printed the actual array, and then this is what we pass into the method. So if I was to, for example, search for the letter B, or actually Z, right? There we go. So this is the array, and inside of this array we want to search for the letter Z. So now that we have those two arguments coming into our method, let's go ahead and do some search. So what we're going to do is use a for loop, and this will be for, and then char, and then C in, and then letters. Or actually, let me simply say letter. There we go. And right here, we are going to do a comparison between the search letter that comes into our method against every single letter in this array. So here I'm going to say if, and then letter, and then equals to search letter. We want to do something, right? We want to do something. So what we want to do is actually increment a counter. We need to keep track of a counter that will tell us how many times that a letter appears in our array. So here, just before the for loop, I'm going to create a variable. So I'm going to say int and then count equals to 0. So initially this will be 0. So if the letter, right, that we are looping through is equal to the search letter, I'm going to say count plus plus. So I'm going to increment count. And to be honest, this is all. Now, the last thing that we have to do is simply to return the actual count. There we go. And this is our method right here. So now if I run the actual method, so this main method, and you can see right here, so right here we are passing the letters, and then we are searching for Z. So if I run this, you can see that Z appears in our array 0 times, right? Now if I go ahead and search for A and then run this, A should appear 2 times. Let's search for D, or actually capital D, and there we go, 3 times. So 1, 2, 3, and then C appears 1, and let's try N, and N does not appear, therefore it's 0. So there you have it. So we've built our very first method, and you can see that this could be really anything that you want, and this is what programming is about, right? So programming is about you solving problems by creating methods and then writing algorithms inside of those methods, right? So an algorithm is simply a sequence of steps to solve a problem. So here, this is our algorithm, right? We are searching for a letter and see how many times that it appears in an array. This is just a quick introduction, about methods. There is more to it, which I'm going to show you later. But if you have any questions, go ahead and drop me a message. Otherwise, let's move on. All right, now let's learn about classes and objects. So a class is a blueprint to create anything that you want, right? So I remember I used to, really struggle with this concept, but I want to make sure that you really understand this concept. So let me just take this lens right here. So you can see this is my Sony lens, right? So what a class is, so a class is a blueprint for creating these lenses, right? So for example, whether it's Sony or Canon, they have their own, machines for creating lenses, right? So those are the actual blueprints, right? So how these lenses are constructed, right? So that's a blueprint. You define basically a template of how to create lenses, and then from that template or that blueprint, you can create multiple lenses. So then you have the actual template. You say, now I want this lens right here, right? And then from that same blueprint, you can create this other lens, but with different attributes, right? And these two individual lenses right here, these are the actual objects themselves. So this is what an object is. An object is anything, literally anything that you can think of in the real world. So here we have a lens. So this is the actual object, right? So what creates these objects are the actual classes or blueprints. So the same with, I would say, for example, this sticker, right? You could literally represent this in code, right? So here you could say, for example, the color, the text, so on and so forth. So with classes and objects, right? So when you define classes, and I'm going to show you exactly in a second. So with classes, they have two things. They have the attributes. So these are the things that define the actual objects that you want to create. For example, this lens right here. So the attributes would be, for example, the color, the aperture, right? So those would be the actual attributes, whether it is prime or not, the brand. So these are the attributes, right? And then the behaviors is what this lens can do, right? This lens can focus, right? And also in combination with the camera, it can take pictures, right? So this can focus, and I think basically if it's prime or not, then you can actually zoom as well, right? Another example is, for example, my phone, right? So this phone right here. So technically I could represent this in code. Literally, I could represent this in code. I could have a class that defines the template for creating mobile phones, right? And then I could create a bunch of objects. Now, this all of a sudden is actually the object that was created or instantiated from a blueprint, right? And in software, everything is based on classes and objects. And on the second part of this course, you will learn about OOP, so object-oriented programming. And this is where you'll see, like, you can literally define objects for everything. Objects, you could represent anything in the real world, anything in software, basically anything you want. So this is an intro of classes and objects. If you have any questions, go ahead and let me know. Next, let me actually show you this in code. Right, let's go ahead and create a blueprint or a template, right? So, let's go ahead and create a class that allows us to create lenses. So you saw that my lens, right, is a Sony lens, is prime, and the focal length is 85 millimeters. So we can represent that in code by creating a class. So a class is a blueprint, and then from that class we can create the actual object, which will be the actual lens. So to create a class, go ahead and right here after the public static void main method, go ahead and simply say static and then class and then lens, and make sure that you have these curly brackets, right? So now inside of this lens, we can define some properties, right? So we know that, a lens has a brand. So we're going to represent this as a string. So string brand. And let's also say that we have the focal length. So focal and then length. And we can also know whether this is a prime lens or not. So Boolean and then is prime. Now we have the actual properties of this class, right? So now we need a way for us to actually create objects by passing some properties. So let's go ahead and simply say lens, and then within parentheses simply say string and then brand, string and then focal length, and then Boolean is prime. So let me put this on a new line so you can see everything. Now add curly brackets And this guy right here, it's called the constructor. So the constructor is how we construct these objects, right? So what I'm going to do here is simply say this dot and then brand equals to brand, and then this dot and then focal length equals to focal length, and then this dot is prime equals to is and then prime. So when I say this, I'm referring to the current instance of the current class. So you're going to see this in a very second. So this now is our blueprint. So this is our template for creating lenses, right? So just bear in mind that the reason why we are using the static keyword is because we want to be able to use this class inside of this public static void main. So there are better ways of creating classes, i.e. having a file with this class in it. But for now, I just want to keep things very simple and in one place. Now that we have the blueprint for creating lenses, or the blueprint or the template for creating lenses, next let's go ahead and create two lenses based off this template. Right, to create a lens based off this template right here, so class lens, let's do the following. So let's go ahead and simply say lens, and here let's go ahead and simply say lens, and then 1 equals 2, and then new, and then lens. So you've seen the new keyword, right? So as soon as I say new, this variable right here, so this guy right here is the actual object. So this is the real thing in the real world that we are modeling, right? So that we are representing. So this is the actual lens. Now in the constructor, so this guy right here, so this guy, we said that we accept the brand, focal length, and its prime. So the brand, let's simply say that this is Sony. And let me put this on a new line so you see everything properly. And then comma, and right here focal length, let me simply say 85 and then mils, and next whether it's a prime lens or not. So let me simply say true, right? So this is a prime lens, right? So that's a bigger lens that you saw. So there we go. So this now is the actual lens. So this is an object. We've done it. We're actually representing something in the real world, right? So the template now allows us to create as many lenses that we want. Literally, we can create thousands of lenses, right? And this is what happens in the real world. So the actual blueprint for creating lenses, so these are like in factories. They have all these machines that can create bunch of identical lenses, right? But they can tweak few things. They can change the color, they can change the actual focal length, so on and so forth, right? So we are doing the exact same thing with our blueprint or template. And then here, when we say new lens, and then we pass all the information about the lens that we are building, then we have an object. So this guy right here. So you see that we have brand and then column. So don't type that, because this is IntelliJ helping us to know what the name of the argument should be, i.e. so right here. So it's basically taking this name right here and then saying that the first argument is called brand. So then it just helps me to know that this is a brand. So I could say Canon, for example, right? So Canon, right? But don't type brand. So basically I'm saying don't do this. So brand and then column, and then don't do that, right? So if you don't see that, it's because IntelliJ is not giving you the suggestion for your argument. So here, let me simply say Sony, And let's create another lens. So I'm going to copy this and then paste that. I'm going to say lens and then 2. So the other one was a 30 mil. And finally, let's go ahead and create a third lens, and this will be lens and then 3. And for now, let's simply say Canon, and then the focal length will be 24 to 70, and then mm, and then this is not a prime lens, so simply say false. So there you have it. So now you can see that we have 3 lenses. So now that we have these 3 lenses, next let's go ahead and actually print to the console the actual attributes for each lens. So let's go ahead and create or actually let's simply say south and then lens and then 1, or actually 1 like that. So let's simply say south and then lens 1 dot and then brand, and then let's duplicate this 2 times, and we want the actual focal length. The actual is prime value, and let me grab all of this again, and then let me simply paste that in. Have some space here so you see exactly everything. So lens 2, and this will be lens and then 2, or actually not 3, 2. And then let's copy again all of this and then put it here, and then lens 3, and then this should be 3, just like that. Now let me go ahead and simply run this program. So if I expand this and let's add some spaces, so south print line and then south print line here. So let me run it again. There you have it. So if I expand this, you can see that we have on the console lens 1, and you can see the details. So Sony 85mm, true for whether it's prime or not. Then we have lens 2, it's Sony 30mm and also prime. 3, Canon 2470, and then false is not prime. So hopefully you can see that how classes and objects work. So right here we could actually have more information, right? So we have the brand, but we could also, for example, include the actual model, right? So string and then model. We could also have string and then color, and then perhaps the actual price as well. So price, and then the actual weight. So the actual weight of the lens, and you can see that we can model this with a bunch of properties, right? So when I say we can model anything that you think of in the real world into code, I mean you can. So this is how you do it with classes and objects. So this is just an introduction about classes and objects, but I'm going to show you later in my other course exactly how to build classes and understand the properties and behaviors, and also having methods and the best practices for creating classes. So this is all for now. If you have any questions on classes and objects, please do let me know. But remember, a class, so this class right here, is a blueprint for creating objects. And what an object is something that models something in the real world. This is all for now. Catch me on the next one. Alright, so I just want to give you one more example of classes. So you saw that before we represented the actual passport and a number as a string, right? So let's say that we have this passport number, right? Now, technically, there is more to it when you want to represent a passport. So you've got the country, you've got the expiry date, you've got the issue date, so on and so forth. So let's go ahead and actually model a passport. So right here, let's go ahead and simply say static and then class and then passport. So make sure the class starts with uppercase. So here, passport. Now we can have the actual number, right? And then let's also have, for now, the actual expiry date. So we're going to represent this as local date and then expiry and then date, right? Now let's go ahead and have a constructor so that we can create multiple of these. So passport, and we're going to have string and then number. We're also going to have local date, and then this will be the expiry date. Now this dot and then number equals to number, and then this dot expiry date equals to expiry date, right? So number, so this right here refers to the current instance of the current class. The same with this local date expiry date. Now that we have a passport, so again, you can have more than these two attributes. I'm just keeping it simple for now. Now that we have a template for creating passports, let's go ahead and create a passport. So passport, and let's say that we have UK passport equals to new and then passport. So number 12, or actually let's just keep it simple, 1. Actually let me put like a real number. So let me put this on a new line just like that. So number 1 2 3 4, and then expiry date. So this is local date and then dot of, and then we have to pass the actual year. So 20, let's say 2025, and then 1 and then 1. So that's the actual month and day. Now let's go ahead and have another passport. So passport, and then US passport equals to new and then passport. There we go. And let me grab all of that. So just gonna grab that and then put it there, and let's change this to 999, and you can see the expiry date. Let's say that this is 2030, right? Just like that. So we can actually have one more property here, and that is the actual country. So string country, and then here string and then country, and let's also pass country here. So this dot and then country equals to country, and I put this on a new line so that you can see everything. And now we have an error because we have to pass the actual country as well. So this will be England, and then let's simply say UK, and then here, oops, not there, so here and then here. So now we have USA, just like that. And there you have it. I'm missing actually a comma there. So this is just another example of classes so that you see that we can represent anything that you want, really. So if you have any questions on classes, please do let me know, and I'll try and give you more examples. Right, I want to congratulate you for reaching this far and completing this course. So I absolutely had fun teaching you Java, and the next step for you is to enroll to my Java Essentials course. So in Java Essentials, we're going to continue what we've learned in this course, and I'm going to touch upon more advanced concepts. So the goal really is just to keep on improving your Java knowledge, and at the end of that course, you will fully grasp this language, allowing you to start building applications on your own using, for example, frameworks such as Spring Boot, Quarkus, and many others. So it was a pleasure teaching you Java. And before I forget, if you're not part of the community, go ahead and join the private Facebook group as well as Discord. The community is growing and I would love you to be part of it. This is all for now. Give me a thumbs up so I can keep on providing courses like this, and also subscribe to my channel. I'll catch you on the next one. Assalamu alaikum.